This is what they call a bench to bedside story of the development of a drug in the laboratory, which is then tested in humans to show that it has activity in centers of learning and memory in human volunteers. Our discovery that we've made in Alzheimer's disease is that we've used molecular principles to design a new drug. A leading biotechnology company called Sosei Heptares developed this drug, allowed us to test it in animal models, and then together we've taken this program forward and used it in human volunteers to show that it has activity in the brain regions which we want to target for treatment of memory loss in Alzheimer's disease. With current treatments, you cannot give sufficient drug to give you the memory benefits without having the adverse responses. And so when you look at this and you say, what's exciting about this? Well, of course, it's hugely exciting to have something which is much more precise in its molecular mechanism to treat learning and memory deficits in Alzheimer's disease, which is desperately needed. But even bigger than that is that we've put down a roadmap which is going to allow for other studies against other molecular targets to use the principles and approaches which we've developed here to treat other diseases using the same broad principles of molecular targeting, structural-based drug design, and then leading on to animal models of disease and then eventually into humans. That's a step a fundamental researcher rarely makes. And so now this is a real prospect of hitting the clinic within the next few years. For us, we are interested now to take this forward mechanistically to understand the underlying biology of the action of these drugs so that we can make next generation drugs which will be even better. And also we're probing the prospect that drugs of this nature might not just be symptomatic in their action, but could what they call disease modify, in other words, slow or prevent the progression of Alzheimer's disease.